Okay, good afternoon, folks. Welcome to the inside and outside of text for JavaFX, the graphic details. I'm Phil, that's Thor. We both work in the graphics team at Oracle on JavaFX, and I also been doing JDK stuff for a long time. The stuff we have to put up, you must read it very carefully. Okay, so here's the roughly out of the agenda that we'll be going through, I won't bore you anymore with that, but you can read it for yourself. We'll see as we go through. Okay, so as an introduction, I just wanted to say, why does text matter? Well, it's when a user is interacting with an application, and for the most part, I mean, okay, if we're talking games, it's a different story, but most applications, particularly productivity applications, almost even other applications where people are doing more fun things, a lot of the time they're actually reading text, labels, selecting things, and so that's what they're focusing on, that's what they're looking at. There's all these pretty pictures in the background. If they're looking at a web page or something, they're reading the content. There's the ads and whatever else in the backgrounds are often make it pretty, but that's not what the user is spending most of their time focused on. So it's everywhere. It could affect the performance of your application, and there's a lot of subjectivity around what makes text look good and bad. If you were to go on the web and search around, you'll see that there are been some interesting debates between people who insist that Windows does text right or wrong and Mac does text right or wrong, and in many cases it's just straight down to what the individual is used to. The other side is wrong, let's go to war. So this is just as a slide to sort of get it over. If you look at this demo, which is supposed to be the Ensemble is one of the demos that you can download that shows off all the different features of JavaFX. If you're familiar with Swing, you'd know it's basically like Swing Set, except it's got even more in it. It's got so much in it, I don't think I've actually explored it all. But it shows off the different charting, and so this is actually demonstrating charting, right? A very graphical thing. And yet, there's one little pie chart in the middle, and most of the content on this page, the tree, the labels, the description stuff over here, the labels on the chart, labels on the tabs, everything, text. Okay, so that's why text is important. Let's just talk a little bit about the basics of text on computer displays. So there's some very ancient history, but this is really where we are today. Pretty much all the fonts that you'll see used on a modern desktop, or even on devices now, feature phones like my high-tech one here use bitmap fonts. But if you've got an Android device, or you've got one of those iFruit phones, whatever they're called, then they're using outline scalable fonts. So basically, the standard font format these days are called TrueType fonts, or they at least started out that way. And then the new version of the standard app, after Apple went off and did their own thing, became called OpenType. It's not completely open, really. Microsoft really control the way the spec goes. What it attempted to do was unify TrueType and PostScript fonts by letting you have the same font file format, overall file format, but you could have PostScript outlines in there. And then there's other sort of derivatives of this, such as WOF fonts, and I mentioned a bit about this later. JDK supports PostScript Type 1 fonts, which are commonly used still in printing and other stuff like that. But we don't actually, even though JDK supports those, we just decided not to bother supporting these. Pretty much all of the designer fonts that you'd get these days come as OpenType CFF fonts. So I don't think Adobe are even creating any more PostScript Type 1 fonts. So there was no point in trying to support that legacy format, which introduces a lot of complexities if you want to support multiple master fonts and all the rest of it. So the basic idea is that inside the font file for each glyph or character, there's a description of the shape, and there's some software that will create an outline at the size that you need, and then convert that into an image, and that's what actually gets displayed. And that's the basic of it. Text rendering terminology, you'll hear people talk about black and white or bi-level text or whatever, or alias text, which is the old bitmap text you would get on Windows 3.0 or even Windows 95 or even actually Windows XP if you weren't turning on ClearType. And you can still get it now on Windows 7 if you want. It's what X-Windows used and so forth. But pretty much everyone now does some form of font smoothing. Takes out the jaggies, it makes the text look a lot smoother, and you can actually use it to make the shapes look a bit more sort of ideal. And then Microsoft and others introduced the idea, I mean Adobe had their thing called CoolType, and I forget what everybody else called theirs, but there are ways of actually making text look a little more high resolution on an LCD display by using some characteristics of the display. And there's an image somewhere later on that shows you what that means. Hinting is basically when an outline needs to be adjusted to the pixel grid so that at small resolutions you've got a small glyph image where you're trying to do like 12 pixel high text, right? In the black and white, in traditional, bitmap fonts, should I say, each bitmap was hand designed, right? And each size, you've got a bitmap for that size. Now you can actually do that with TrueType fonts as well, but the other approach is that there can be a way of embedding instructions or hints or whatever you want to call it, which actually take the outline and tweak it at a particular size so that the way that outline was going to go somewhere between the 2 pixels, and I really want it to snap off here. I don't want it to go down there. It means that text is overall sharper in anti-alias mode, and that it doesn't look quite so just ridiculously horrid in pure black and white mode. Characters versus glyphs. So in your application, you're using the Java application at least, you're referring to a Unicode character code. So people are familiar with this at this point, I imagine. But Unicode has defined probably like getting on for 100,000 characters with all the different extensions now. And those don't all even fit into a single font file for what it's worth. But the font has to define some subset of these, like it may only support may only support Cyrillic, for example, or it may only support Latin. There's not like a big empty space in there. There's just a table which says, Unicode characters for A is it glyph index 12, or something like that. And so there is a mapping from the Unicode code to the glyph code, which is a font-specific reference. And the information there, essentially, by mapping through from the glyph code, gets through to the outline of the font, and eventually you can get at the image by the process I talked about earlier. Metrics. So it's basically a way of talking about how text is measured. In most graphical primitives, and text isn't quite as primitive as some things. If you're talking about a circle, it's very obvious what the dimensions of the circle or a rectangle are. I mean, you defined it, right? And you know that if you want 2 rectangles to a butt and you made one 10 wide, you've got to move over 10 units to the whatever direction to place the next one adjacently. But with text, you can specify that you want 12 pixel font, and you can have your character A, but you don't actually know how wide A is. I mean that's determined by the font and the font designer. So the logical advance is basically the difference between the default placement of one character or string and the next, so you would know how to position things. Baseline. Traditionally, if you're drawing a rectangle, the origin is generally the top of the rectangle. But with text, typically the origin that you specify to draw whatever, the draw operation, is the position of the baseline. So most of us are familiar with the sort of Roman baseline on which we for above which our capitals go and descenders go below that. So the design height of a font is how far it typically, the typical design height of all of the different of the capitals, or maybe a little higher than that for the font, depending on what the font's targeted at, and the descent is the design height as to how far it goes below the baseline. And if you add these together, perhaps with a line gap, which in some fonts is 0 or infinitesimal, you get what the overall height is of each particular line. So the overall logical bounds is then the horizontal advice by that font height, right? But a very different thing, which we'll have some slides on later, is the visual bounds, and that can be quite different. The little images here to the bottom right are intended to try to show you. The upper one is showing what the logical bounds of this italicized F could be, whereas that is completely different from the visual bounds, the actual bounding box touched by the pixels that are rendered. Okay, so that's all I was going to say about the sort of basics of text, just to sort of set the scene for that. Let's start talking about what we do in FX. The text class is a node in the SceneGraph. I think Thor's got some slides which explain what the SceneGraph is for those people who don't know later, but essentially it's a graph of objects in a hierarchy, which is the basis of the way that the JavaFX API works. And there is a subclass of a node called shape, which adds additional operations. So once you've got any kind of node, and a node, so almost everything in the SceneGraph is a node. So there are UI controls that are defined as nodes, so you can apply all the same operations to them. So they can be stylized CSS, and they can actually be laid out in that SceneGraph. But since text extends shape, additionally, it can have other operations, such as you can apply a fill to it and a stroke operation. And it's an event target, so your text node can receive some input events. So as I think Thor will touch on later, this is actually sort of, this is a low-level graphics rendering primitive, but at the same time, it's actually quite a sophisticated element. Right? It's not just graphics drawstring or something like that, or ext text out if you're a GDI programmer or whatever. Right? It's not just, it's more than that. And this is sort of modulo anything that's been introduced in Canvas. This is really still this is the lowest level primitive we have in FX, and you'll see that it can do an amazing number of things for what is that lowest level primitive. So it's fairly intuitive to use. You basically create a text node and pass in a string at minimal. You can actually set the string as well, and I'll show you some examples in a minute. Probably the most important attribute after the text content itself, perhaps of a text node, is the font that is used. Now, I just talked a whole bunch about fonts, technology, but let's look at what we have here in how you actually apply that font to a text node. So for whatever reason, in JavaFX 1, which was based on on a scripting language called JavaFX Script, which is based on an earlier scripting language called F3, form follows function. Whoever was actually building that API decided that you would obtain a font using the font family with a factory method, font.font. You would pass in what is the family name of the font and attributes, and you would get back a font object as a result. So that I'm not showing it there, but a font object is returned. If you want to use the full name of a font, and you don't use a factory, you use an actual constructor, and you would pass in the full name. So these two methods are both equivalent, so long at least so long as there is an Arial bold, where it's possible you may find that just fails. Right? don't use the full name to the factory method, and don't expect the family name unless it defaults for the regular, which it does in many fonts. Don't expect the family name to work for the constructor. But just because Arial, the default name of Arial regular is Arial, that'll work. That might delude you, but it's not like JDK where you would pass in either name and we'd scratch our heads, try to figure out whether you meant a family name or a full name. In FX, if you pass in the full name to the factory method, it'll just return you a default font. It won't try to figure out that you meant the Arial family. It's just purely looking for an exact match to a known family. Font is also immutable. I just wanted to mention that as an important point because it helps a lot in general in a rendering stack when we receive an object if we know that you can't mutate it afterwards, because if you could, we've got to figure out what that means. If we cache certain rendering state and you mutate it, basically that's a real performance drag. We've got to recalculate everything every time. So it's not just font where you'll see that in the rendering stacks, or many rendering stacks. The alternative is we'd have to copy it on when you set it, which is a drag too. Particularly since we may not even know how to copy it, depending upon the nature of the object. Logical fonts. Could you get me some water? So we have the concept of what at least we call logical fonts. I think other people. Call them logical fonts too, and they're easy ways of getting to something that actually will render using the typical typographical features of serif, sans serif, and monospaced, which can be a real pain for if you go to a platform and you just know that I really want to use a monospaced font, you'd have to go through, and we didn't have these logical names. You'd have to go through some API. We'd have to invent some API for you to enumerate things, find the monospaced font, pick one, and all you cared about is just basically trying to do something tabular. So you wanted a monospaced font. Although monospaced fonts are actually something of a myth in some ways, because no font supports every single code point. So if you require fallbacks, the fallbacks are probably going to come from a different font. And even if it is itself a monospaced font, the widths are probably different than the one that was the first font, so just watch out for that. That's a generic gotcha with any kind of fallback system. So we use the same name, serif, sans serif, and monospace as the JDK uses. That means anybody who's been using JDK doesn't trip over too many spelling mistakes and get very confused. We also added the name system. We don't use the other dialog and dialog input the JDK uses, but we use this system, which was intended to convey to you that what we're trying to give you back here is something that is the typical UI font. So, serif, sans serif, and monospaced, I think generally will map to something like Arial times New Roman and Courier New, which actually is what they were mapping to in JDK. In JDK, dialog also really mapped to Arial as well, but we wanted, what we wanted to get over as well is that there's a font that was actually intended to be the mapping to the UI font of the system, and it didn't necessarily. We didn't want to say we're not saying it's serif or sans serif or monospace. We're trying to say that that if you are on a particular version of Windows or a particular version of Mac OS, we will try, or whatever, we will try to retrieve the system font. We'll try to retrieve the system sizes, and when you ask for the default font on yours from FX, you will get back system regular. Now, people might ask, well, why doesn't it return Sego UI to me, please, if it's Sego UI? Well, because we want people to be able to do something like, say, set font, system font. But, you would otherwise have to, do some, retrieval of what the actual by saying set font system regular, really is what I want people to be able to say, right? So you don't have to go retrieve the font, get its name out, and then create the font at that size. You can just say, I want system regular at this size or that size. But if you, so we don't actually expose, for what I'm getting at as well, is that we don't expose, you can't call it and ask, oh, what is this underlying system font? Maybe there should be a way to do that, but there isn't. And do expect that to be, to change between versions of Windows. So JDK baked in that Arial was the default system font, the dialog basically, and it was on Windows and it was always that, and people came to depend on it and we couldn't get out of it. But for a fact, I can tell you that on XP, you'll get back to Homer and you'll get back Sega UI on Windows 7, unless the user has gone and tweaked their default system configurations. Now, one other point is that users, platforms have, like, oh, this is the menu font, oh, this is the title font, oh, this is the font used on such and such a thing, oh, this is the default font on a choice box. So I forget precisely where we got it from, but these are often configured to the same thing, but could theoretically be configured differently. So we wanted one choice, which basically maps most closely to what you see in typical UI controls, but it may not be, the font that's used in every single place on the platform. You can enumerate the fonts by calling get families or get font names. Okay. Okay, so here's a very basic example of using the text APIs. So you can create a text just with no args. You can say, then specify the text with saying set text. You can set the font using the factory method I showed. You can set the color by calling set fill, and then you can add that to your scene, and that's an actual rendering which was captured from a ping. And as I said, this is a low-level primitive, but we let you add all sorts of styles. You can set underline or strike through, just using precisely the calls they say there. Show that. You can control the anti-aliasing mode, which I touched on earlier, you can see that the top level, that the higher enlarged word welcome is grayscale, whereas the lower one is colored, and the coloring is what it looks like when you blow up LCD subpixel. You can actually see that the different pixels are different colors. And one, I don't know if I touched on this. I don't know if I touched on this here, but the UI by default, maybe I do touch on it somewhere else, but basically gray is better for animation and graphical uses. So on a text node, by default, it is gray, right? So if you want to get LCD, you've got to turn it on explicitly. We thought about having LCD be the default, or maybe on this platform or that platform, or maybe the default should be based on whether it was an installed system font, because that's how Windows renders its installed system fonts. Well, except some Windows APIs do that and some don't. So anyway, the choice we made is you get gray by default and you turn on LCD. And one of the things you'd find if you were to look closely is that all the default Caspian CSS for Windows basically enables LCD in all the UI controls. So your UI on Windows uses LCD, except on a raw text node where it defaults to gray, and you would have to set that. On macOS, it's currently defaulting to gray. And it's interesting to know where we'll actually go with this as we head into sort of like mobile and embedded space, pretty much, and high resolution displays. So things like iOS, right, do not even support LCD text. And with high resolution, once you get above 150 dpi, LCD is starting to lose its value. And it's a more expensive thing to do as well. So, and the fuzziness of grayscale at small sizes goes away once your tiny text that you can barely see is actually like 20 pixels high. It's actually a pretty decent sized glyph. So I think, grayscale is, LCD is, here and it's going to be used for a long time on a lot of devices, but the real high-res devices like Retina displays and these things that are going to come along on mobile devices like iPads and Android pads are going to be just all using grayscale. And there's different display technologies as well. OLED actually makes it a bit more difficult to use LCD as well. Okay, so we can do other fancy things. Gradients. Here's a simple example. We're basically setting 2 stops, which will basically mean that we transition from red to blue across the length of the string. So just by adding these, it's a fair number of lines actually by the time you've created the stops and passed in all the parameters to linear gradient. Maybe there's some more defaults that you can use, but just a couple of lines, and that fairly boring blue text string can become a very nice gradient. And this is just a simple gradient. You could actually do something even more flashy. For example, you could take that gradient, and I've already applied the gradient to it, and I could set a drop shadow. So now that starts to look really nice, and you didn't have to write a lot of code for this. You just created a text node, set a few properties on it, and bang. And remember, this is our low-level graphics primitive, right? CSS. CSS is actually fairly widely used within JavaFX. For people doing controls, the idea is that you'll be able to do a fair amount of separation between all of the logic and the layout and so forth, and have somebody else who can work in a designer tool actually apply styles until they think that the aesthetics of the application are good. So there's a default style sheet which we would load, and then you can apply your own style sheet to your application, and then for the text node, it would probably look inside the style sheet. It could look something like that. But you could also do the same thing from code on the specific text node by setting the same string using the set style method. So it's interesting actually to understand how this all works. At the bottom is the output of this partial code of this code snippet. So in the first line, you'll see I've created a text node 1. I set the font to be Arial bold, and I'm just using that font name as the actual text. So you can see the first text node displays Arial bold. So text 1, clearly the font, that set font call, has taken effect. Now text 2 set style, I do FX font and set Courier new using set style. And then I get the font, okay, that font as a string, right, back from whatever is the current font on the text object. And remember, I just called set style, and I say that is the text. Okay. Now I say, forget that. I'm actually going to override my call to set style, and I'm going to explicitly set the font on the text node to be Arial bold. So this should look, even if the string isn't the same, the string should say Courier new, right? Because that was the font I just set with set style, but it should appear in Arial bold. Well, none of these things happened. The font that was actually on, that we got, even after calling set style, was the default system font, regular. And the font that we set last, Arial bold, isn't what was used to render. So what basically happens is that set style, when you call it from code like this, is deferred until what we call the per frame sync pulse, right? So when basically we copy stuff over to the render thread, we take this, at that point, all the CSS styles that have been explicitly set are applied. And so it actually happens at a later time, right? I was thinking about even doing a little example where it shows you how you might try to get the bounds after you set the font, and you might be surprised. Anyway, that's sort of, there probably should be a way of setting these things immediately, but just that's a little gotcha to watch out for. Now, this low-level text node, that's basically a drawstring, can also do multi-line text. So here I insert a new line character into Java 1, and boom, you get 2 lines, just like that. Right? So drawstring wouldn't do that for you. Drawstring would have just interpreted as null. But you can also set a wrapping width. And I set 200 pixels here, and this slightly longer string wraps at 200 pixels, regardless of whether there were a new line. But if there was a new line, it would wrap immediately when it hit that new line and start again. And we can align multi-line text. So here you can set left, right, or center, and I think it's pretty obvious which is which there, I hope. And you can justify that multi-line text to the wrapping width. So we're adjusting the space between the words here in order to make the text align to the wrapping width. And the last line is not justified, because it could be, but I think it's more normal to do it like this. Okay, so I need to go orderly quickly. Got some examples. So the text bounds, understanding text bounds. So in FX there are different bounding rectangles for all the different node types. I don't know if everybody's familiar with all of them, but bounds in local coordinates should include, in theory, the stroke and effects, but it's untransformed. Bounds in parent basically applies the same thing, but transformed in the coordinate system of the parent. And layout bounds doesn't necessarily include the effects because it's used for actually, placing things within the SceneGraph, and the effects are not accounted for there. But I talked on earlier about logical and visual bounds, and we actually have most nodes and most node types, most graphic primitives, right? You're thinking only of visual bounds, but text has the concept of logical bounds, and it's really the more normal way of thinking about text. So actually, logical bounds is the default. So, and generally speaking, this gives you some kind of looser bounds, but it doesn't necessarily enclose all the pixels. So you can see the red box, again, shows you that the left and rightmost parts of the italic F are outside of the visual bounds, but at the same time, the height is actually, is way too much to account for the height of the F. And visual bounds are much tighter. So it'll depend what you want, but the default is logical. And if you really want tight bounds, because you're treating this more as graphics than text, then you would want to use visual bounds. So just recapping that, the height that you're getting is really not about the particular string you're drawing in logical bounds mode. It's more based on the properties of the font. And if there are leading and trailing spaces in your string, that's logical. That's logically part of where you would put the next string, right? If you've got separate English words, hello, world, just because you can't see the space doesn't mean that you abut world right up against hello, right? It's got a logical existence. I'm not sure what word to use. Visual bounds, the tight bounds can be more expensive to compute. I mean, historically, we've actually made it's been really, really much more expensive to compute. But for the most part, we've managed to make it not so bad these days, at least in FX. But, if content's changing, right, visual bounds may not be what you want. So there's a quick example. If I've set bounds type visual, you could see that, because of the way that this flow pane works, it's using this actually non-exposed property called baseline offset, which doesn't really change based on whether you're using visual or logical bounds. And so when it tries to align these two strings, you can see in the logical bounds mode, the underlines line up and the strike throughs line up perfectly, but the text is offset. So, it could be argued as a bug, could be argued that we should, try to either make flow pane or baseline offset adjust. But, I'm really just trying to get over the point that, visual bounds isn't necessarily the thing you want for aligning text. You can dynamically load fonts. JDK had a very, very similar capability. So you give it a URL. So I made up this URL, so don't go looking there. But very simply, you pass in a string. There's no string quotes in that. Well, that won't compile, will it? You will, so if there's a font at that location, now that could be anything that is a valid URL, we'll load the font, and you can then use that font directly. Actually, there should be a parameter. My bad, there should be a size parameter there as well. So you get back a font you can directly use at that size. And the sort of boilerplate kind of thing that you could do here, if you wanted to embed it in your jar file, is to basically pull it as a stream out from your jar file, so that you would bundle it in your application as well, which is probably the more normal way of doing it than pulling it directly off the web. Web fonts. I think it was 2.2 was the last release. We started supporting web outline font format, whatever it's called, web OpenType font format, which is really the OpenType or TrueType fonts were although they could be subsetted or what, the key thing is that individual components with tables within the font are sort of zipped up and it's got a different header. And you can, and Google has a web fonts project, and you can actually go off and reference these things directly and get a web font reference back from them. And there's two different formats actually. There's the one that works for at least. There's the EOT embedded OpenType, which is for IE or Microsoft APIs, and everybody else I think supports the WAF format. And in FX, we have this WebKit, a like Safari-based embedded browser called WebView. And so now if you actually go to a web page which actually has web fonts, WebView will actually directly load that font, and so the web page will render as the web page designer intended. You could also directly use these a WAF font in an FX application using load font and get the file. But I think the more normal way is like, I don't think I have the CSS, no. If you were to look at the way it's actually defined on the web page, if you were to go to like Google Web Fonts, and you'll see the HTML and then JavaScript it generates, and CSS. That's actually what people would probably want to do in their applications, but we need the people who do CSS support in FX to actually add that capability. So it's, I don't think anybody's going to be going off and getting a web font and embedded it in their app, but they could if they wanted. It would actually work, but using it via CSS isn't yet available. So I just wanted to switch to a quick demo mode. I don't know that I'm going to spend a lot of time on it, just due to lack of time. This tries to show off a bunch of the capabilities that we had. Due to the fact that I switched the screen resolution, you can't see everything, but this tries to sort of show all the different capabilities we have in FX. You can set the font size. We can stroke. I didn't really show you stroking, but basically that's an outline path for the font. We can change opacity. We can obviously rotate, transform the font, scale it, shear it. Shears go off very rapidly. I would have to switch resolution to get down. You probably can't tell very well if I switch on LCD mode, so I'll skip that. We can adjust, I don't think I showed this, text origin. As I said, default is baseline, but you can set whether you want the origin to be interpreted as the baseline or the top or the bottom of the text. You can, the barely seen yellow and green boxes are showing the layout bounds and the bounds in local, or sorry, actually bounds in parent maybe. But if I switch those between logical and visual, can you actually see? Yeah, you can see the green box. If I take off the scales off here. You can just about see the box become more tight. What can I don't know actually how to get to the bottom of my demonstration. There's some more things down there, but I have to set I can't get it because it's too big. All right, I'll show that to anybody individually later who's interested in features I didn't show off. Okay, let me, one other thing is we have, oops, slideshows, from current slide. We have a, I'll touch on some of this stuff in a minute, but one big piece of functionality that we are adding back in the next release is that because JDK FX1 used to use JDK support for complex text, and FX2 basically rebuilt things, we ended up losing a lot of the capability. But I just wanted to briefly show that we will be getting that back. So if you were to look at, is that the right one? There's the right window. If you were to look at FX2, which is currently shipping, this is what this looks like with a mixture of Hebrew and Arabic, Devanagari, some font that where we're using Latin diacriticals, and if you do the same thing over here in the new version, which isn't yet shipping, but you can download the binaries, this now renders completely differently. So this on the left, I'm afraid, is what we're shipping now is, I'm afraid, garbage. But on the right, you can see that all of these things now line up. Text is properly right to left. I was going to show a line breaking demo as well, but I'll skip that in interest of time. So we'll go into some of the internals now, and then I'll hand over to Thor momentarily. So I touched on some of these technologies earlier on. In JDK 1.1, it used the platform APIs, which is GDI and X11. Really, we supported Windows and Solaris. JDK 1.2 came along with Java 2D, and we were supporting grayscale text in a time when you could really only get it if you went out and got Windows 95 OSR2 or something. Basically, none of the platforms supported that. And TrueType support was a fairly new thing. Complex script support was added in 1.3. 1.5, we improved a lot of things. We added LCD text in JDK 6 and added clear type rendering in 6U10. And at that point, we seemed to be pretty much done for what we needed to do in JDK. But then FX came along. It was starting again. And the requirements for FX were actually quite different. We were targeting initially web designers and so forth. And in some ways it's like a Flash competitor. We'd struggled a long way to get Windows native rendering kind of compatibility, and then it was like, well, that's not what we want. We don't care about that. What we actually want is some other quite beautiful, more Mac-like rendering than what like Flash does. It's animations that are important. So some of the things were good. We were getting for free all that complex text and so forth, but it wasn't the actual rendering that we wanted. And also, people were going off and getting designer fonts like these OTF fonts and then putting them in FX, and they looked awful. And it's like, what's wrong with your font rendering? Well, you load them into Windows. Windows did the exact same thing. These fonts were not designed to be used that way. So GDI agreed with us. The problem was with the fonts, but that it was still something that we were had a target. And unfortunately, we then, we were heading in that direction, adding certain capabilities into JDK to try to emulate that. And then FX2.x came along. We were no longer going to use the underlying AWT and swing stack and depend upon that. We have a new stack built from the bottom up. OpenGL 3D will scale from devices all the way up. And but now we have lost all of that JDK rendering. We're literally not allowed to call it. We're not based on that. It's not there. Even if you're running on top of JDK, you can't touch that stuff. So we had to start off and create a completely new text implementation. And I think Thor is going to be talking now.
Okay. Let's see. Yeah, it's more like 10. Okay, so the design goal for text, well, first of all, internally, JavaFX uses text all over the place. So, in fact, any text rendering will be handled by our text node. So, whether you're using a web, whether it's a web view or sliders, it's labels or buttons, it will end up having a text node there. And from a design perspective, obviously, we need to keep the text node as lightweight as possible. We would like layout, etc., to be able to create as many as it wants. It needs to be flexible, take any amount of text, and perform well, and have all those features that Phil has outlined. Turns out to be quite difficult. So I'm going to sort of delve into the details of rendering and see the internals, but might as well start at the top, which is basically SceneGraph. This is a node, it belongs on a SceneGraph. I'm sure everybody knows that, not that exciting, but be aware that there's actually two SceneGraphs. There's your public FX SceneGraph and what I call the render SceneGraph, which handles the rendering. These are on two different threads. That way they can do their work simultaneously. And they are synced up basically on the frame holes. Now, there's that hidden text node, which is called the peer of a text node that you have on the FX SceneGraph. It has some of the same hierarchy, etc. But it's called ng text. Ng text extends ng shape, and ng shape extends ng node and base node, etc. So I want you to remember that. So we go to the next slide. So, which is wonderful, it inherits all that capability of the base node. You can translate it like any other graphical object and do most things to it. It has the attributes of shapes, so you can stroke it, etc. Which is all wonderful. Now, what does it mean to put a node in a SceneGraph? Well, I came from a low-level API where I was using something like OpenGL. You had to manage rendering, you had to loop it. In a game engine, you're constantly doing work, and that's acceptable. For us, well, that's all hidden away and it's taken care of for you, whether you like it or not. But all you have to do is create a node, put it on a SceneGraph, and poof, it's visible. And you would expect, hopefully, when it's not being changed, that we do no work, that we were lazy. And yes, we try to be lazy and as possible, both at work and for coding practices, algorithms. And the way we manage this, we mark these, so we don't want to obviously render nodes that are not visible, and we really only want to render the ones that have changed, that are animated across, etc. So, so the nodes that need to be re-rendered are basically marked dirty, okay? And this is accomplished basically by monitoring properties on the text node and verifying that yes, it has changed significantly. We will have to re-render this thing. And but that's not enough, right? You could have something below it or above it. You have a button and text on top of it or image below it. You change the state of that button. You clear the area. You re-render it. That's not enough. So the SceneGraph needs to worry about the rest. So it basically has to find all intersecting nodes that have intersecting nodes to those dirty nodes, and also mark them dirty. So on the next pulse, all those nodes get rendered. Now this is done intelligently. This is oversimplification. We don't obviously do this excessively, but and it works out pretty well. So, but there's a cost, obviously. The SceneGraph needs to be aware of the size of everything that it has. And for text, that's not obvious. And when you start out as a text node, you basically, if you want to be really lazy, then you absolutely do nothing. You get text as a string, you have some font sizes, some scale values, etc. But in order to get the bounds, you really need to do layout. So, and furthermore, bounds is not enough. It's not just the layout. we need to incorporate all the extra content, as Phil pointed to earlier. So if you look at that little F that we're reusing again and again, it's basically the blue box that we need to find. And that is a little bit more costly than the red one, which is that data is embedded in the font. So, and then we have that wonderful inheritance. You can do almost anything to a text node. You can apply all the effects that you can do. That you can do it to any shape, etc. But, well, there's weight there. You know, for example, the base node itself has over 24 member variables currently, and this could change in the future. They're all very important. They help the state of rendering, etc. And we almost can't live without them. And they have shown to, you know, the extra data has been evaluated carefully, and it has showed better benefit than, you know, extra cost. Shape is pretty lean and mean, and text, it wants to be a monster. I mean, every feature that we add, I mean, it's just the basic stuff: the string, the layouts, the selection colors, indices, fonts, bounds type, etc., are on the node, and we have 2 of them, somewhat. But I think everybody deals with this. You see the browsers and so on are consuming massive amount of memory. I think we do pretty well. So the consequences of these constraints, well, this SceneGraph needs the bounds of the node. This text must lay out all text provided accurate bounds. The minimum we can render generally is the node. This is a serious oversimplification, but text node is a little bit dumb. It looks at the clipping, but sometimes it thinks of itself as one single entity, and it wants to render everything. Okay, and yes. So we try to make it as lightweight as possible, but it's not the size of your string. It's definitely a lot bigger. So keep that in mind. Don't go crazy. Don't put all the world's documents into one text node. It would be a very little point. You wouldn't see it on the screen anyway, and you will have to pay the layout cost currently. So this might improve in the future. So more about graphics rendering. We have different pipelines that we support. We try to use the hardware pipeline. That's the default, which could be D3D or OpenGL, and most D3D on Windows. Everywhere else, OpenGL or ES2 for embedded. Now, if your drivers aren't capable or are blacklisted, etc., then we will have to fall back to software. Software is pretty good. We have the J2D pipeline, which is basically Java 2D as a fallback, which is JavaFX 2 only. And then there's the new software pipeline, which is SW name, which is going to be in JavaFX 8. So, sort of quick, how do we produce these glyphs? What's the process? So this is rough, hand-wavy, simplified explanation, because it's fairly complicated. We have to map each character to a font that supports it, as discussed earlier. And we need to map each character to a glyph code. The glyph code does correspond to a glyph. And this is definitely not one-to-one mapping all the time. We need to check see if the glyph code, actually in this case, exists in our glyph cache. So we maintain a large texture, which has all that data. Yeah. And we texture map the quotes, etc. I'll speak against the graph. So this is kind of our call sequence. It's not properly named. It's not, but this is how basically the text node uses other things in order to do what it needs to do for rendering. So here, the text peer obviously needs to talk to layout a little bit to find out a few things. We render on a different pipeline, Anyway, well, let's look at the data. It's more interesting. So this is the data flow. And so the peer text node essentially sends a whole bunch of glyphs and glyph codes down to the render pipeline with fonts, transforms, so on. The pipeline sets the appropriate shaders and things of that nature, and colors and states for that hardware state machine. Now it looks in the glyph cache to see if to find all those glyphs in the glyph list, and basically changes that over to a quad, texture map quads. If the pixel data doesn't exist already, then we have to do a little extra work. So we have to look in the font, rasterize it, and so on. But once that work is done, we never have to rasterize again for a given glyph while the texture is valid, which is typically the case. And that all gets outputted and composited through a surface. Okay. So that was grayscale. LCD is slightly different, not by much. So LCD is, the glyphs are 3 times wider. So the normal source over blend mode doesn't work, so we have to do special math and a special shader to do the blending on a subpixel level, basically color level. And also, because the blending isn't supported, we need a copy of what we're going to be rendering into. And this has been annoying because most hardware today doesn't allow us to sample from and render to the same target. So we need a little copy. Recently, LCD shader, LCD shader handles transparent backgrounds, and which I think we're the first to do. And I was going to show off a demo here. Just quite briefly. And we're off.
Okay.
So that was okay there. So that's LCD text on.
Speak closer to that one.
That's LCD text on transparent surfaces. On a transparent surface.
So the point is that most platforms sort of bail when you get to transparency, LCD text, whereas we just seamlessly transition.
So here we try to use as much data as we have. Here it looks like we have a bunch of color in the background, but when we're rendering, we don't have access to that. That's the operating system that takes care of that.
Okay, all right.
Well, there's one more thing.
We need to get really.
I wanted to show what is happening. So this is the image we saw earlier. Here's the sample, and here's the LCD text rendered on top of it, and here's the mesh. So this is all the glyphs and with the texture map. And then there's a texture with a copy of every glyph, every transform somewhere. That's it. Go ahead and switch.
Okay, I'll skip over a couple of slides actually. I think we'll just need to get a shift on. So performance basically is very important to us, and so accelerated graphics definitely helps sometimes, but sometimes you're just bound by the cost of rasterization, of the cost of actually going to the font, getting the font information off disk, turning it into an image. And caching is actually a really powerful tool, but it only helps if the glyphs are actually reused. If you've got a pathological application which never uses a glyph, then hardware acceleration will only help so much. But in a lot of cases it will, and for typical applications it will. And we can actually get some pretty good results. And so we can talk about how heavyweight things are, but we actually do things pretty well. LCD text is more expensive, even in hardware. Certainly in software, I remember Microsoft, saying that they consider it to be like a 30% overhead to the actual lowest level text rendering, or maybe even just overall it came up that way. And there are, and these things have pluses and minuses. So, LCD text might be greater quality. Some things, if you want higher.
Skip the GUI mark, maybe?
Yeah, I'm going to. Yeah. So. And if you want something like subpixel positioning or whatever, you're taking an additional hit. So quality, and performance for a trade-off. And we're going to be working on these. And I want to just show you a couple of sort of demos to kind of get over where we are. So there's a fairly standard benchmark these days for, I don't know, people may not say it's actually brilliant, right? This is actually HTML5 running in Firefox for this text rendering demo test. And it shows you the frame rate it's getting up there. As far as we can tell, that's about as fast as it can go. And the Flash one goes about, something like that. Okay, so fine. This one is JavaFX running in the same applet. And we are getting 160 frames a second, 170 frames a second. We actually, and that is, for what it's worth, I don't even know if I'll bother showing it because of time. That's the current shipping version. The new version actually, I think, gets something on this machine, something closer to 600 frames a second. So lots of performance there. Okay, I'm being wrapped up. Okay, so let's just put up a summary slide, close the tabs. Sorry, I can't find my mouse. Yeah, I know. There's so much we wanted to say. Okay, so where's that not doing anything? Okay, so we think we're already pretty featureful. We know we've got deficiencies. We're pretty fast, but we're going to be working on performance and quality. Complex script support is coming. There'll be rich text, which I haven't touched on at all. Felipe is working on that. And there's a URL here for walking through some of the API usage that we discussed. And that's actually, you can probably quite easily find that on the Oracle website. And with that, thank you very much.